what if I tell you 4 to the x equals 7 to the 2x plus 3? So I have an exponent equal to an exponent. So I have 4 as a base and 7 as another base. So there's nothing in common with 4 and 7. So I can't put it in that form that we saw from the beginning. B to the m equals b to the n. So I have to manipulate this a little bit. So I'm going to take the log base 4 of both sides of this equation. Log base 4. So these are going to cancel out. So I'm going to get x is equal to log base 4 of all this stuff here. So that would be 7 2x plus to the 2x plus 3 power. Now, when you study logarithms, there's a property that you would have seen. So it's called the power property. So if you take log base b of x to the n, you're allowed to bring the power in front of the logarithm. So this would really be n times log base b of x. So it's called the power property of logarithm. So that's exactly what I'm going to do with this. So I have log base 4 of 7, 2x plus 3. So I'm going to bring this whole entire thing in front of the logarithm. So I got x is equal to 2x plus 3 times log base 4 of 7. Here my x is my argument, here 7 is my argument. So this has to be multiplied by the logarithm. This is a times here. So again, I have to apply the change of base formula for this, because this is kind of a messy one again, just like the last one. So if I apply the change of base, what's that going to be? So this is 2x plus 3 times ln of the argument, so ln of 7, divided by ln of the base. So we have ln of the argument divided by ln of the base. So the argument's in the numerator and the base goes in the denominator. Same thing here, same thing here. So ln of x over ln of a. So ln of 7 over ln of 4. So of course, this is just going to be a number, right? It's going to be a very messy number in the end. This whole thing is a number. So what I can do is I can apply the distributive property. I can distribute ln 7 over 4 to 2x into 3. That's allowed. So if I distribute this, it would be that would be 2 ln of 7 over 4x plus 3 ln of 7 over ln of 4. So I have to distribute it to each thing, right? Here. So 2 ln 7 over ln of 4, x. The x has to still be there someplace. And then 3 ln 7 over ln of 4 is what I get on this side. So this is just like an equation with variables on both sides. I have to get the variable on one side of the equation. So I'm going to go ahead and subtract this part from each side, and then I'll have it on one side of the equation. So whatever you do to one side, you have to do to the other. So I'm subtracting this whole thing from both sides. So it'll give me x minus 2 ln of 7 over ln of 4 x equals this thing over here. 3 ln of 7 over ln of 4 is what we get left. So x minus 2 ln of 7 over ln of 4x equals 3 ln 7 over ln 4. So we have to factor out the GCF, which is the variable that we're trying to solve for. So if I take an x out of itself, then I get a 1. If I take an x out of this, then all I get is this thing. So it'll be 2 ln of 7 over ln of 4 x equals 3 ln of 7 over ln of 4 on the right side. So again, these are all just numbers. So whatever this is going to be some decimal number. This whole thing is going to be some decimal number too. These are multiplied together. So I can go ahead and divide both sides by 1 plus all this junk I have inside. So whatever you do to one side, you know by now has to be done to the other in algebra. So this whole thing is going to just cancel out, leaving me with x, which is what I'm trying to solve for. So now I need a calculator to do all this stuff here. So if I do the top part, I'm going to get this 4.211032.383 on top. And if I do it on the bottom here, I get 3.807354922. So if I divide the two numbers, I get that x is approximately 1.106 to 3 decimal places is my final answer. Any questions? So it has a lot of steps, but this can still be done. Okay, let's see what else I have.